I do want to get going because I'm thinking there's going to be a lot of questions and conversations on this particular Lunch and Learn. So let's go ahead and get going. You ready, Dan? I'll give you a quick introduction, and I just want to go through some Zoom etiquette, everyone. But welcome to our 9th Lunch and Learn for 2022. I am your host, Janine Burke-Wells, with the Northeast Biosolids and Residuals Association. Everyone should be muted as you enter the webinar, and I'm going to keep you on mute until the end, and then we can open it up. You can speak directly with your questions and comments. There's also a Q&A function at the bottom of your screen. I'll keep an eye on that as well as the chat, so feel free to chat or ask questions as we go through the presentation. This session is being recorded, and the link to the recording and the slide presentation will be provided to everyone who signed up for this webinar. I'll also make it available on demand to our NEBR members. So thanks again for joining us today to learn about reed bed treatment systems, and specifically the operation at the town of Buckland, Massachusetts, Shelburne Falls Wastewater Treatment Facility. I am pleased to introduce our speaker today, Daniel Florial, and he is the mostly retired chief operator there. He started in the business when he was in the Air Force, where he served as an environmental support specialist, which means he worked on sanitation matters, including water and wastewater treatment systems, as well as swimming pool maintenance. He did his 4-year hitch in the Air Force and then went to community college for engineering. And while he was in school there, he heard about a part-time position at the Sunderland facility in Mass, and he worked there for a couple of years. And then Shelburne Falls put out a call for help, which he answered, and that's the beginning of the story. He went from temporary to a permanent employee in May of 1984, and he's been chief operator there since then until June 29th of this year. So he has decades of experience operating reed bed systems, and I'm looking forward to learning all about them. And I'm going to ask him to introduce Lisa Provencer, who is you're taking over, I guess, and dealing with some of the other issues. So hi, Lisa. Dan, welcome. And I will ask you to go ahead and share your screen and tell us about your reed bed system.
So for the moment, we can leave up that that backdrop there. That's actually a view of the reed beds. And so the treatment plant was built as a result of all the Clean Water Act stuff that was going on back in the 70s. And here in the village, we already had a wastewater collection system in place. It was installed in the about 1910, the same time that they were putting in a water supply system. The collection system was taking all the street runoff. It was taking roof drainage, cellular drains, sewage. Everything was going into one combined system, and it was conveniently going into the Deerfield River. I think there was 4 or 5 points in the river that the wastewater was going directly into. There was no treatment at all. And so in 1974, the facility here was built. There was nothing before that point, and they built an activated sludge treatment process on the Buckland side of the river. On the Shelburne side of the Deerfield River, they put in a pumping station, and with that pumping station, everything from the Shelburne side was pumped to the Buckland side. And then the existing system was redesignated as a sanitary sewer, and almost all of the street drainage was disconnected from it. And since then, more of the connections have been found and eliminated. And right now we've gotten to the point where we've got nearly all of the inflow sources eliminated, and the flow here at the facility is considerably less than what it was back when the plant was first built. They did have a lot of stuff to get rid of. Most of the collection system at that point was the clay pipe, and at that point it was already 60 or 70 years old, and it was getting to the point where root intrusion was a common problem. So when they built the plant, they also purchased a machine for trying to rod out and clean out the sewer lines. Mostly there was not an issue with blockages, but over the years, the root problem has gotten worse, and through EOCD grants, we've done a bunch of sewer line replacement. We've got rid of a bunch of the clay lines, replaced them with PVC piping. They're watertight new structures for that are going away from the brick ones to the precast ones. And throughout this year, actually, the INI has been extremely low. There was also another big project in town where we had part of the trunk line coming to the plant, which was still mostly the clay pipe, and we're somewhere in the range of between 50 to 60% of the collection system is more recent than 1974. They did put in some transite, some asbestos concrete pipe in 74 when they converted the collection system over. And so now we've got pretty much a little bit of everything. And the problem of the INI is nowhere near as bad as what it used to be. It's quite manageable at this point. And whereas when I came here in '83, pretty much any rainstorm would cause us to wash out solids, and it was two-pronged problem. One of them was the rate that the flow would increase. The other problem is at that point, the solids handling of the facility was nowhere near what it needed to be to stay ahead of the process. And if you can't manage your mixed liquor solids level, you really have no way of keeping the effluent clean. So the biggest thing that we had, when I first came here was the solids dewatering was deficient. We had sand drying beds, they were uncovered. I think 23,000 square feet, 34 by 74 foot sand drying beds. And that was the entire dewatering process available at that time. And in the wintertime, the engineers thought that we would just hold on to the production of sludge in the winter, and then we would resume dewatering in the spring. The reality was it was nowhere near enough. And so initially we tried to set up a lagoon to hold our winter sludge, and then we were going to land apply the liquid sludge in the spring. And we did that 1 year. We had a lagoon that was built that was 120 feet by 60 feet. It was lined with a Hypalon liner, and it certainly held the volume that we needed, but we had an aerobic process. And after the digester, it was going into the lagoon, and it promptly went septic, and the odor was brutal. So DEP said, okay, that's the last time you do that. We're not letting you do that again. They did let us land apply the sludge that 1 year, but from that point on, we weren't able to use either the land application or the lagoon. But we did repurpose the lagoon. The lagoon we allowed to fill with rainwater, and for the next several years, we had a belt filter press rented, would come in, it would empty the digester of 52,000 gallons. Then we would waste a bunch of sludge out of the process, put that into the digester, and then waste that. And 2 to 3 times per winter, we'd have them come in and keep us cleared out so that we could continue to keep our solids in a manageable place. Then the next thing we tried was we looked at either having a permanent belt filter press installed, or that was when we first started to look at the reed beds. And the cost came out considerably more for a new building and a belt press than what it was going to be to convert the existing lagoon to a reed bed. So what we did was put some sand and underdrain in the existing lagoon, which had a 7-foot depth to it, and put in a pump station, and then the filtrate that came down through would get pumped back to the beginning of the plant and then run through the process again. It was mostly clean. It had a somewhat higher concentration of dissolved solids in it, but it had most of the BOD removed, and it was a combination of both the precipitation filtering down through the cake and the filtrate from the sludge itself. So we tried the first reed bed. It wasn't big enough to handle all our sludge production, but it was a proving ground. And at the time we did our reed bed, the Sunderland Wastewater Facility also put in an installation in their sand drying beds at their wastewater treatment plant. The treatment plant here, our digester is an aerobic digester, and at that time it was a surface aerator. And the surface aerator was doing a good job of aerating it and keeping it mixed, but it was also not really doing well as far as holding on to the temperature, the heat inside it. So although it was somewhat working, we weren't really getting a real stabilized sludge with the digester. It was close, but not quite what we needed. The Sunderland treatment plant, their digester was diffused aeration, but it had no roof over it. And in the wintertime, its temperature went down even further than ours did. And because of that, they weren't able to aerobically stabilize their sludge. So when theirs went to their reed beds, it went septic on the beds, and the reeds are not happy about having an anoxic condition in the root zone. And so the roots, although they can transfer a small amount of oxygen down to them, they can be overwhelmed. And if they are overwhelmed, the reeds won't grow in it. So they ended up with essentially a ring around the edge of their reed beds of growing reeds, and everything within the center part of it was completely void of any reeds. So they ended up discontinuing theirs, and they had to go somewhere else for their sludge disposal. So with the success of the first reed bed in 93, we went to going full on with the reed beds with 2 more cells. At this point, the town still had a landfill that was in operation, and we were able to take our dewatered cake on the sand drying beds up to the landfill and dispose of it there. And after that was closed in 95, we were pretty much going to have nothing for an option. The reed bed wasn't going to take all of it, and any of the facilities that were taking sludge were not taking sludge from sand drying beds, because it had, when you take the sludge off the beds, it takes some sand with it. And any facility with incinerators did not want to have any sand coming into their incinerator to destroy the fire brick on the inside. So we either had to go with what pretty much everybody else was doing, is going to handling the sludge as a liquid, hauling it away as liquid and going to other facilities, or to double down on the reed beds and make those work.
Excuse me, Dan, Did you want to share any of your slides?
Yeah, let's go ahead and switch over to the,
All right.
the 2008 presentation. This was originally,
Share.
Yeah, I'll let you control the,
okay. All right, so let's see, pretty much talked about this. All right, so talked all the way through that. 74. All right, so this is our layout here.
hang on, I can't see it.
Do you have that?
No, I don't see that. I'm gonna pull up your, I have your slides here. I'm just gonna show that. Can everybody see that? All right. Right here. This
Yeah,
is
here
a
we
good,
go.
this is good.
Okay, so the circle on the left is the drying beds, which after we had, before we had the reed beds, we put a greenhouse enclosure over the sand drying beds, which actually helped out a lot because it allowed us to dewater even during the winter time. It would still freeze, but we could get the sludge cake off before it froze down to the sand. And we were still using that up until 95. And then once we couldn't go to the town landfill anymore, then we stopped using it as dewatering, and now it's a storage area. It's still in a bind. We could still apply to it, but it would mean moving a lot of stuff back outside. And all right, so we've got the aerobic digester. Initially, when we put in the reed beds, we changed from the surface aerator to diffused aeration. We initially had coarse bubble diffusers, which worked pretty good. The blower was a little bit oversized, and since then we have downsized both the blower, and we've changed from the diffused aeration to from coarse to fine bubble. And we also increased the number of diffusers we had. And so now we've got the same size blower in the aeration tanks as we have in the digester, and the both the aeration tanks with circular diffusers and then the digester with the tube diffusers. And now we've got a pretty consistent, well-stabilized sludge for going to the reed beds. The BOD on the sludge is typically somewhere around between 800 and 1500 milligrams per liter. And the sludge concentration it ranges depending on how well it decants from about 10,000 parts per million to, am I off by 10? The digester sludge, TSS.
Yeah. Oh, okay. Go ahead.
So we added the upper beds in 95, bed 2 and bed 3. They're a completely new construction. And at that time, we had something that was going to handle all of our dewatering needs. Let's see, do you have? Weekly. There we go. Okay, 10,000, yeah. So if you want to bring up going to the reeds. So
There we go.
Is that this year?
Yeah.
So total sludge production has been somewhere in the range of 350 to 400,000 gallons per year. And that's been pretty much what we've been doing right along. Our sludge production hasn't really changed much in the last 20 years. And let's see, so, oh, there we go. The way we do this is to give the digester the best opportunity to get the sludge as digested as possible. We're on a 3-week schedule. And so if we start at the beginning of the cycle with a nearly empty digester, we don't empty it right down to the bottom. We'll leave 3 or 4 feet in the bottom. And we'll waste for 2 weeks, which will fill the digester. And then the following Monday, we will decant off the supernate and thicken it. And then we'll apply sludge to the digester for another week. And then after the 3rd week, we'll decant on the following Monday. And then that Tuesday, then we'll go to the reeds. And that will, when we go to the reeds, we'll take out about 3/4 of the volume of the digester. And all right. The only thing that we have for adjustment is as the digester is, biology is happening, it has a tendency to use up the alkalinity. So we'll use hydrated lime and we'll just dump that directly in and then let that, that does a pretty good job of maintaining the pH, the bugs stay happy, and it doesn't really add anything to it that we're really concerned about. It's hydrated lime, most of it dissolves. And so the reeds get the sludge applied to it every 3 weeks year round. The only time that might back off a little bit is during the summertime. The production of the sludge is a little bit less, and it might go to a 4-week cycle. And other than that, it's a process that's going on year round. During the growing season, the reeds will come up in about middle of April. The new rhizomes the shoots will come up through the existing cake layer, and then they'll grow for several months. They'll reach a height somewhere in the range of 10 to 14 feet tall. And the nutrients make them grow a little bit taller than what you'll see them when you see them in nature. Sometimes they'll be in maybe the drainage swale of a highway. There might be a stand close to usually cattails. Their desired environments are pretty close together, and one or the other will take over an area and then pretty much make it a monolithic stand. It'll be either all reeds or all cattails. We haven't found the seeds to be very viable, and that we haven't had an issue of them sprouting up all over the place. And although the seed tassels they're kind of like dandelions, where they would probably go great distances in caught by the wind. When we get to the end of the growing year, after frost, the top parts of the plants will die off, the leaves will drop down, and we'll basically have a stand of straw with tassels on it. And then in either in the fall or in the spring, before the beds have thawed, we'll cut those down and burn them in place. Let's see, we'll drop down one more level, one more slide. So that's a view of the first reed bed. We've got right there is at the end of the season, you can see the fall foliage. That's there's a catwalk going through the middle there. You can't see it because it's it's right there somewhere. There's the distribution trough for the sludge is in the middle of the two beds, and there really isn't any issue with it spreading throughout the bed. It flows pretty nicely at 1.5% solids. It flattens out on the whole thing, and we don't have to do anything exotic with the distribution system. When we did the second and third beds, we had it so that it came down along 4 sides, but we found that was unnecessary, and pretty much it dumps out at one point in each bed now, and it's fine. So we can go another one down. This was, we cut down the reeds. We've got a sickle bar mower. It's turned out to be the best way to get it cut down, although it's still a wrestling match because the stuff you're cutting down is 10 to 12 feet tall, 14 feet tall, and when it lays over, it goes everywhere. But the only thing we do is we get it away from the edge, because the edges of the reed beds still have the hypalon liner, and we don't want to have the fire anywhere close to that, risk burning a hole through that. And burning it is pretty quick. It's a pretty clean burn, and then any of the ashes will all pretty much stay right there, and all of that stuff stays in place. Just to the left of the flame there, that's the roof over the digester. The digester has got, the roof is a 2-wall design. The inside wall is insulation, 2-inch foam insulation, and then on the interior side of that, we've got plastic as a vapor barrier to keep the heat inside. Then there's an air space, and then there's the paneling on the outside and the metal roofing on the top. And to try to gain as much heat as we can for the winter, the air that gets drawn in for the blower actually gets drawn in through the soffits, and any of the heat from the sun on the metal roof will warm up the air a little bit before it goes in through the blower, and then from the blower, it goes right straight into the tank. And in the wintertime, we'll have the air going in to the sludge somewhere around between 120 to 150 degrees after the compression. In the summertime, we actually have to vent the blower room so that we don't get it over 200. And in the summertime, the temperature of the sludge will be somewhere in the range of 90 degrees. The temperature of the sludge in the wintertime doesn't normally get down to much below 70 degrees. And that's coming from sludge that we're wasting to the digester. Summertime mixed liquor temperatures 75, somewhere around there. And then the wintertime, the mixed liquor will be down somewhere around 40 degrees. And so we get a fair amount of heating and heat retention in the digester, and then we don't get anywhere near the biology during the winter, but because it's going out on the beds and then freezes on the beds, we don't have an issue of the beds going anoxic while we're putting that out there. And the freezing is actually a pretty beneficial thing that happens. When the sludge itself freezes, the ice crystals penetrate everything, including any of the microbes biology, and once they're split with a crystal of ice, when the ice melts, they split in half and everything lets go, and we end up with a nice consistency of material that is a little bit more granular and not pasty as what you would get from cake coming from like a belt press, or even sand drying beds that didn't freeze. Right, let's see, go up the next, let's see. Okay, so this is when we first started the reed beds, we had some minor issues. And the reeds themselves are apparently delectable for aphids. And so the aphids would really ravage the leaves. And so we got some ladybugs in to eat the aphids. And that kind of, that went two directions. We ended up with a lot of ladybugs sitting here and eating aphids, and coincidentally, there seemed to be in a neighboring town an abundance of ladybugs climbing all over any white house in town on a few specific fall days. I'm not taking credit for it, but I can't rule out that it might not have been some of our escapees. The other thing was we did have some tomatoes came in. The tomato seeds do survive the pretty much the whole treatment process, and so they would not survive the winter, but they eventually did get taken over by the reeds, and now it's mostly monolithic. We don't have much of anything but some one bed. We've got some nettle that grew around the edges, but that's it. When the beds were first planted, there is a risk of having them freeze down into the sand where the roots themselves were planted. And so we could control the water in the bottom by setting the level of the floats in the wet well and maintaining a certain amount of water underneath them and way to transfer heat up to the roots and keep them happy. And the first year it was relatively thin. The second year it really filled out quite a bit. And by the third year, it was a pretty dense population, and it was from that point on, there really wasn't any issue with the reeds. And our current distributions piping is the number one bed has got a pipe going through the center of the bed, and it has holes drilled on the top and then slots connecting every other hole, and it kind of comes out the top of the pipe and dribbles down the side. And then the main thing is initially you don't want to bore holes through the sand layer where the reeds are planted. And once you've got a layer of cake on there, then that issue goes away by itself. And for the next few decades, you pretty much let it spill out and it's not an issue. And let's see, there we go. That's what it looks like. So that's the reed bed number one. The catwalk there has the top of the sump for the leachate collection, and then from there we've got a small pump that pumps it back to the headworks. When we go to the beds, we're pumping there with a trash pump, and the trash pump will we crank that right up, and we'll be able to waste the typical application to the three beds is somewhere in the range of between 28,000 and 30,000 gallons per application. And that will happen within probably 2 hours.
4 hours.
4 hours for all three beds. And then once we break it down, then we basically have nothing to do with sludge dewatering for 3 weeks. And comparing that to what we were doing when we were doing the sand drying beds, in order to keep up, we had to do an application to the beds every week. And we weren't getting quite as thick sludge, and so we were usually doing about 12,000 gallons to the sand drying beds each week, and then 5 days of drying, a day to remove the dewatered cake, and then another day to flood the beds again. With the sand drying beds, we were using polymer. This is the view of the upper beds. We've got distribution pipe coming in, and the pipe comes down, it goes to a T, and then it goes to some pipes that just go off and dead end in the top there. The piping on the distribution is set up so that when we shut down, all of those lines that are exposed will drain empty on their own. The one quick note, that valve there, that's a 4-inch ball valve. It's plastic. And when you freeze a ball valve with sludge in, whether it's the valve was in the open or closed position, the sound is like a shotgun going off, and the pieces of the valve will travel about 40 feet. So we have learned that one the hard way. Our process now is once we're done with going to the reeds, we'll leave these valves in the half open position. And then that way the chamber around the ball is allowed to lose the sludge that's in there. And then you don't have a spot where the sludge will be able to build up pressure and break the housing. We'll do that again. So this is looking at bed 2, and bed 3 is in the background. Actually, you can see a little bit of an arch to the distribution pipe going to that, so that, yep, there you go. So part of it will drain into the beds and empty out. And then the way we do it is we'll start out with beds 2 and 3. We'll apply to these 2 here. And then when we're done with these here, then we go to the 3rd bed, which is off view down over the banking to the left. And then when we finish with that one, then we can allow all of the lines to drain empty. On the right-hand side of the screen, we have a diagonal pipe coming up along the slope of down a little bit. There we go. So the underdrain system is vented. We have, so that we don't end up with an air pocket underneath that might trap the filtrate from going down into the underside. This lets any air out, and then we don't end up with any bubbles coming back up through the sludge application as we've applied. This is in the spring, early in the spring. We've already cut down, and you can see the black area. That's some of the leftover ash from burning. And closer to the edge, you see a bunch of the leaves that are still there. And we have a good water supply down here. We've got the town water's 150 PSI, and we use town water to stand by with hoses around the side, so that when we do burn, that we wet down the plastic beforehand, so that we don't get that bubbling and curling from radiant heat. And also we'll wet down the areas outside, because all of that will have dry tinder in there. Let's see, we can go, all right. So we really did have a sweet deal when we still had the landfill open. I think they were charging us $7.50 a cubic yard for the land volume value, which was an unrealistic number, but okay, so let's see, fall of 2007. So to excavate the first bed in the fall of 2007, we had no really good way to reach all the way out to it. And we got a hold of a long reach excavator. It had a 55-foot long boom. It looks real weird, but it was able to reach out far enough into the bed. We also had a second excavator, a smaller one, that was going out and working next to the bed on the far side and transferring it to a point that the other one could reach. And then from there, it was being loaded into trailer dumps, and the trailer dumps were going up to Casella's landfill in up near the Canadian border. the, let's see. And for that excavation of just the number one bed, the total cost, the trucking, the excavation, and the disposal was $46,800, and that was in 2007. If we, and this was written in 2008, so at that time, the cost per year based on those numbers was about $20,000 a year. And so up to that point, things looked really good. And if we had emptied beds 2 and 3, and now we need to empty bed 1 again. If we'd have done that 4 years ago before PFAS had come along, we probably would have been able to done something with it. But now, back then, the only thing we really had to worry about was the copper. The water supply system's a little bit low in alkalinity, so we end up with copper in both the water, and it ultimately accumulates in the sludge. And our copper level was over 1,000, which was a cutoff as far as DEP was concerned. And we're typically in the 1,400 milligrams per liter for copper here. And although it's relatively benign, and if you start looking at what the PFAS may turn out to be as far as a problem, that the copper is really not that big of a deal. But so we're now, okay, there's our long reach excavator, and we've got, I don't know if you can see very well, there is a red-tailed hawk perched on the very peak of it. You can just see, yep, you can just see a little bit of the white of its breast there. It was scoping out the area and keeping an eye on things. And then this is during the excavation. We've got the small, we initially, so that the operator could see what they were doing, we used the skid steer with a bucket to knock down the reeds, and the other excavator there we were using to transfer to within reach of the large one. And the material was brought down, not all the way to the sand, although it did get exposed a few times. We left a little bit of the cake there so that we would end up with some roots staying in place. And then we did not replant after the initial removal of the cake. We just let it start growing the next year. The skid steer there, okay, this is what we looked like after the winter. There is the new reeds are coming up. You can just barely see them there. This is probably the end of April. We've got leaves on the tree already. So end of April, beginning of May. And when we started, the cake was, I think you can see at the, under the catwalk there, there's actually a little bit where it was still at the level of the old, yep, that's as high as it got up to when it was full. And so if we go next slide. All right, so I was hopeful to get a hold of a sod farmer. We have a few sod farms in the area. Deerfield has got some. And I brought some material to the person that owned it, and I could not even get a meeting with him to bring the reed bed cake to replenish the soil where they had harvested the sod. They take about 1 inch of the material, which is mostly roots and a little bit of topsoil. So we haven't really got any place to bring it at the moment, but what we're working on now, that's what the reed bed cake looks like. Those are the roots, and they're really prevalent below the surface. They grow throughout the layer of cake above the sand, and there's probably some still alive down in the sand. And we'll go on to the next one. I think I've got one that has a ruler with scale. Okay, so that's a 12-inch ruler. That's that ruler. The roots are not quite as big around them as my wrist, but they're pretty big. And about every 6 inches or so on the right-hand side, that's actually going to be a rhizome that will come up, and they're segmented. It's kind of like crabgrass, and they just continue to grow sideways throughout the bed underneath. And actually, if a reed falls over early in the year, it will send out roots at each nodule and then send up new rhizomes from there. Yep. And it'll do essentially the same thing as a root does. And here we've got the following spring. We do have some weeds in there that got started, and once the reeds grow up a bit, they get starved out for light, and they ended up dying out. And the only thing that we've got as far as the distribution system is here we'll continue to make it through the process, and it gets snagged a little bit on the distribution pipe, and we just pull that out as we're applying. That's me and my work uniform at the time. And so now that bed there, we're filled right to the brim. And now on the contact information, do we have the right phone number? Okay, good. I made up a, yeah. So that's the treatment plant phone number. The email is no longer at crocker.com. And the email is at town.buckland.ma.us. And that, if somebody wants to get a hold of us here, we can send that to them. Nick Tooker is actually the person that put together this whole PowerPoint. He was working for Ty and Bond at the time, and he gave me co-authorship on this because the process was done here, and I don't know, maybe he wanted me to stand up and present it at the meeting in 2008 up in Vermont. He works at UMass now. He's not with Ty and Bond, but he's still he's in the education end of things now. And if somebody, that phone number there for Nick Tooker would not work, but if somebody needs to get a hold of Nick Tooker, we can arrange for them to get a hold of him. And so going forward, we've got an opportunity that we have with the reed beds. We can sample at different points in the process. We can sample our influent for PFAS. We can sample the effluent of the wastewater for PFAS. We can sample the sludge going to the reed beds. We can sample the filtrate after it's come out of the reed beds, which would be helpful if in a land application situation, if it was going to migrate from the cake to the ground, that would be good to know. The reed beds are pretty much going to mimic a land application situation, with the exception that instead of being on land with sludge applied to it, this is pure sludge. And so if anything land applied would have a lesser amount getting into the ground, because you wouldn't have the concentration of the sludge. The only time we did land apply sludge, it was a one-time thing. And if we were going to be land applying our cake from here, it would not be an annual thing or a biannual thing. We would be land applying once every 20 years. And the rate that it would accumulate on any one site would be much less than places that had regular land applications. There's a plant north of here that was doing a paper mill or a cotton mill that was land applying their waste locally to farms. They didn't have any PFAS in their process, but it was about 95% industrial and 5% municipal. And so we do, with my pending retirement a year ago at this time, Lisa took the lead in doing the dealing with the PFAS and researching that. And so our best hope looks like it's going to be to go to the existing or the closed landfill, which has a liner on top of it. The bottom and the sides are not lined, and so it doesn't meet today's standards. That's why they closed it in 95, was it didn't have the liner underneath it. And so if we can land apply it to the surface there, we have the acreage necessary to land apply it and allow it to stay on the surface. We got a permission a year ago, two years ago, to go to patch the holes. 2 years ago, DEP gave us permission to make a blend with our cake with some topsoil to repair some slopes that had the surface topsoil wash away that exposed the liner. And it turned out it held in place very well, even though it was on the side hill. And so our hope is that with testing the site, testing the soils, testing the ground, which is also already has the monitoring wells from the landfill from when it was closed, that we would have sampling points that would demonstrate whether or not this was an appropriate way of handling our sludge without doing something wrong with the PFAS.
So, Dan, I have a question. Thanks for bringing that's on everyone's mind now. But you're getting ready to excavate bed 1 again? Is that how I understand it?
All 3 beds are full, so we need to excavate all 3. So we've got 18,000. We have 18,000 cubic feet material that we need to find a home for. And so it's going to be just excavating and transporting it short distance is going to be a pretty significant amount of money if we have to go the same route we went back to 2007 to put a truck to sell up north. The cost of that, the trucking that's going to be several $100,000, somewhere in the range of $500,000.
Yeah, it's definitely not easy. Let me just see if we have any questions from the audience at all. So are you aware are there any other of these facilities operating around here?
So initially when we started this year, there was a few facilities in Vermont that had tried it, and as far as I know, I don't know that any of those are still in operation. There was I think Sax River was one of them that had a process. I don't think they had quite as much square footage per gallons a year of sludge that they're using, and so they were relying at a faster gallon per square foot per year rate. I think the theoretical number is 20 gallons per square foot per year. And our number, I can't remember that off my head, but our tree don't count quite that much. And so they're built up in 19 years. And then they, I don't know, they continue to use it after they execute the first time. So Sunderland was the only one in Massachusetts I know of. They tried it for years, and after the bed smelled like chicken manure, they gave up on it, and they started. They must be having a hallways like this because they don't have dewatering equipment on site.
You're starting to break up a little bit now, and actually we're getting to the end of our time here already. I can't believe it. I don't see any questions here, probably because you did a good job thoroughly explaining the process there. So I want to thank you guys so much. That was very interesting, and I learned a lot because I was not familiar with these systems at all, and it's pretty cool. Then I also want to thank the rest of you, everybody out there, for joining us. We did have to cancel our November Lunch and Learn, so this is the last one for the year. But I'm starting to line up these for next year. And if you have an interest, particular interest, please email me, and I will try to do a lunch and learn on that topic next year. So with that, I wish everybody a happy Friday, a nice weekend, and thanks again to the folks at Shelburne Falls.
You're welcome.
Bye, Lisa.